Good morning. Welcome to the new chapter of Spring Boot. I'm Brian, meet Stephane. We're both working on the Spring Framework and Spring Boot teams. And this morning, we're going to talk about the upcoming major versions, especially Spring Boot 4.
Should we ask some the usual questions about what versions they use and etc.?
Yeah, we can try.
Who's not using Spring Boot first? I'm interested.
A few hands. That's
Yeah,
interesting.
all right. Cool. Spring Boot 2.7. A few. All right.
3.0 to 3.3. A bit more. Yeah, right.
It's time to upgrade. 3.4, 3.5. Okay.
Yeah, 3.5.
4.0.
Liar.
Well.
Technically not.
All right, so good morning, everyone. It's great to be back. It's also an opportunity for us to meet friends and colleagues. So that was great. Another perk of being here is that we find bugs.
Yeah.
And we found quite a bit preparing the demo today. So for instance, the new compact format for main methods in Java 25. We wanted to show that. It's not a big deal, but actually it doesn't work. In fact, now it does. But when we try, it doesn't work. And then some of the things that we wanted to demo, we've realized we forgot to do it, I think.
Yeah.
So
it's on the way or already done, but we're not demoing with a snapshot this morning. So we're demoing with the latest milestone. But in the next milestone, which will be RC1, most of it's going to be fixed.
So those two are fixed, even though this screenshot says otherwise.
OK, so this morning we'll use an existing Spring Boot app that we have running on 3.5. And this is the matchmaking part of an online game. So our goal is we get requests from consoles and from players, and we want to fetch statistics and profile information. So stats like the player score, their level, and so on, and information about their gamer tag, region, platform, stuff like that. So we're making two remote calls, getting that information, and then queuing the player. And same for many other players on different platforms. And once we have all that, we have an algorithm that looks at their regions and their pings and score, and we're trying to group them into teams and lobbies so they can play against each other. So that's our application. And this morning, we're going to look at what we can do with Spring Boot 4.
All right. So let's have a quick look first on the app. Let's maybe queue a 50 players, which, as Brian explained, that's going to do 2 calls. I shouldn't do it like that because it feels like it's
sequential. Right now, 2 sequential calls with an imperative blocking RestClient. And so here, we can see that the queue is growing. And at some point, when we've got enough players with the score or with their regions, once we have enough, we should have lobbies being created automatically. So here we have a lobby with players with their ping and level. One lobby for Oceania, another one for Asia, Europe, America.
Yeah, Europe, finally.
So this is our application right now. So lobbies being created for players. And this is a Spring Web MVC application in Spring Boot 3.5.6. Other than that, we're using a mustache template views. And other than that, it's just a regular web application, nothing really fancy.
Still using the REST template, though.
Still using the REST template at this point. Exactly.
All right, so it's using Java 21. We'll upgrade to 25. You can do so before or after. It doesn't matter. Spring Boot 3.5 does support Java 25, just as 4.0 does. Let's do it the upgrade. So why would we upgrade to 25, Brian?
Right now, we can do that because it's the latest version. It's an LTS as well. And we can always use better performance at runtime, and we'll get that for free in our application. And that's it. Do you see other reasons?
Well, there is the talk that Moritz did yesterday about AOT cache and Maiden. So highly encourage you to watch that. It shows you how you can use a new feature of Project Laden to speed up the startup time. The talk has many metrics, so it shows you for each step how much gain you could expect. So that's actually pretty cool.
Yeah, so you can already do that, but it's going to be even better in the next versions.
All right. Why is that complaining about linkage error? I stopped it. Wasn't refreshed. Thanks, though.
All right.
All right. So, yeah.
So now we have that, and we'd like to upgrade to Spring Boot 4. So before that, we were just not updating our app. We want to have a quick look at, like, we have migration guides that are being written. We have already a lot of content. We have like release notes and so on. And if we take a quick look, we can see that the GA is coming up in November, on November 20th. We can see that we still retain a Java 17 baseline, but we do have a Jakarta E11 baseline, so Servlet 6.1 and others. There's a big change, auto configurations. The auto configuration module is actually split in several modules, so that's going to change a few things that we're going to see. Some starters were renamed in the process for consistency and fixing a few naming issues that we had. And of course, we have a bunch of new features. So we're going to explore that. And with that in mind, we're going to change the Spring Boot version by using 4.0 M3.
Yeah, which is the latest. Something that's interesting and that's new compared to what you used to do to consume Milestone. Milestone are released on Maven Central, so you don't need to add an extra repository. As you can see, I'm just changing the version, and that just works. So actually, I forgot to do one thing before we upgrade.
Yeah, so because we talked about modularization of the auto-configure module, here's something that we can show you. So in our app, we just have web, but if you type like web client, maybe auto configuration,
web client, yes.
Because web client is reactive. So we do have the web client auto configuration on the class path. It's not triggered, but we have a bunch of things related to reactive classes. You can type also, I don't know, like JMS or Kafka, and whatnot. And those things are on the class path, but they're not triggered. It's just that the auto configuration is there. Once we move to 4.0 M3, you'll see that the class path is much smaller. We don't have all those types anymore. So if you look for Kafka stuff, it's not there anymore. Same from web client. So right now, our starter is bringing just the bits of the auto configuration that we need with the current opinions that we have. So that should already have a lot of consequences. If you, in the past, if you had like some dependency showing up in your class path and you were a bit frustrated because you didn't want that bit of the auto configuration to kick in, that's going to be solved with that restructuring move.
So the REST template builder is gone, doesn't compile, and if we search for it, actually it's not there.
So it's not a package relocation. Some classes were moved as part of that big restructuring thing, but here it's not one of those. It's really the starter changes and the fact that we split the auto configuration. So now if you need a client or just a client, you can use the starter RestClient and you'll get the regular REST template or RestClient clients auto-configured for your application.
So what that means, another way of putting that is if you only take the client now and you start an app that's not a web app, because it's separated, it's not going to attempt to start a web server, which is what you could experience with Spring Boot currently. Also, because we don't have an opinion anymore about what kind of web client you should use, you could have a web MVC application with the web client, or you could have a web application with the REST client, or web application with no client if you don't need it.
So now we should be ready. I think we can show that the app runs, and we can see how. Do you want to do the REST client right now?
What do you want to do?
To run the app at least once to show how long it takes for one player to be queued. To have a baseline for.
Yes, so I need to change that here. Oh yeah, that's not the. I was so quick saying, oh yeah, migration to boot 3 is done. So yeah, one thing that we also changed, there's some areas where we took the opportunity, as usual, for a major to break some things. And one of them is the HTTP headers, which used to implement the map contract, and it doesn't do so anymore. So that's why the here it doesn't work, because that's the assertion from assert.j for maps.
All right, so now our test and app should be right. And what we can use is a sample request to queue a new player. And what we can see is that usually it takes roughly...
No, it's a bit more.
That's the first one, the first request.
Damn, first request, always slow.
So it takes 400 milliseconds, more or less, because we're making remote calls, and those remote things are taking time. So that's the baseline we're working with the current version of the app. So now, next thing, awkward. Now we can do one thing. If you followed the latest blog post that we published, REST template has been recently soft deprecated. So it's not marked as deprecated right now, but reasoning is explained. REST template is on his way out in some future version. So what we advise you to do is to use RestClient. So there are many migration paths. The easier one is to start using RestClient in your code. If you have a REST template instance already configured, you can create a REST client out of it, just wrapping it. And then there's like a more thorough path when you can use the REST client builder that Spring Boot configures and so on. But the API, as you can see, is going to be much easier because instead of having a template style API with a very long list of flat methods in your ID when you're autocomplete, now you have something that's more fluent, that's guiding you in the right direction, but still gives you the freedom that you want. So here, we want to do a GET request, send something to the URI, accept JSON, and then we want to retrieve a body as a player profile. So we want to deserialize the JSON out like this. So it's actually a bit shorter, it's easier to read, and it won't change the behavior at all, because underneath, it's using the exact same infrastructure, the exact same request factories that powers the client. It's using the same interceptors, it's using the same infrastructure. So if you have existing infrastructure in your company for interceptors doing authentication, adding headers and stuff like that, it will keep working with RestClient. So this is a nice improvement for our code right now.
So you can see also that the clients, they're package private for some reason. The reason being that we have tests that need to bind to the mock REST service server. And if you have two templates, the infrastructure doesn't know to which template it has to connect to. So that's a bit annoying, but fortunately, with the REST client, we managed to fix that issue. So let's have a look to the tests. So what I'm going to do is, rather than binding this to the client for each test, now I can just inject it. And changing this, I guess.
Okay, so now we have our builder, we have the mock REST service server.
I can't type.
That we can assign,
Yes.
and then we can rerun the tests. And
not yet.
Things should go
ditch
smoothly.
Ditch that, because we do this automatically, and that should work.
Okay.
Yep.
Tests are green. We're all good. So now, this was the first step where we had the package relocation and starters, and this is also an opportunity for you in your app to figure out if you want to clean up a bit your dependencies. So we tried to make the upgraded experience as smooth as possible, including we have a classic auto-configure module, just in case you want the exact same experience. But other than that, it's also a good opportunity to figure out, like, do I need this? Do I really need that? And you can slim down a bit your class path and make the behavior more predictable. One of the big features that the entire Spring team delivered was around null safety.
Right. So that's something that's not new for the Spring Framework. You might be aware that Spring 5 already has nullable annotations, and it's fully covered already in the previous, Spring Framework 6. It's fully covered in the previous generations. That was mainly for the Kotlin story, because null safety and making sure that null safety is correct is very important when you call Java code, because otherwise the type changes if it's unspecified. So what we did in this new generation is expand that support. So now the whole portfolio contains those annotations. And there's a JSpecify, as Brian mentioned, that brings compile time checks, as we will see. So essentially, if we take the code as it is right now, nothing, and we call, for instance, player ID, that we already got a warning from IntelliJ, because the method that nothing new there, that's something that you would already get in the previous generation, but only for Spring Framework, not for the rest of the portfolio. So we're not saying anything that might return null, and then we use this in a different place. So let's have a look to the different place here. It's essentially our code that does the to call synchronously. And yeah, we just call that, and no null check, so potentially that's a problem. So what we're going to do is configure, show you how you can configure the static compilation checks and what happens.
So with the JSpecify work, which is being worked on by an entire group, now we have the ability to add annotations to our code bases, and those annotations will go very, very far thanks to some tools that you can use. So here we're going to use error-prone as a build plugin, and as a plugin of that, we can use Nullaway, which will look at nullable annotations from JSpecify, and with some configuration, you can express what kind of checks do you want to happen at build time. So here, what we're expressing is that we want to have the Nullaway checks. We only want to check code that is marked as null marked. So null marked is an annotation that goes everything under that package or in that class is not null unless you say this one is nullable. So this effectively says everything is not null by default, otherwise annotated. So this is our opinion right now. We're also saying that we want to look at contract annotations contributed by Spring Framework. We're going to talk a bit more about this. And we're using the JSpecify mode, which is basically adhering to the JSpecify standard. And we want to treat nullaway errors as errors. And that's pretty much that.
You might be surprised by this, because it's like disabling all the checks. It's a little bit strange when we're trying to add one. So error-prone is actually doing a lot of things that are unrelated to null safety. And so in this example, we're not interested by that. We only need to focus to JSpecify. So if we have that and we compile, then nothing happens. That's because we didn't specify, we didn't provide our intention that a specific package should be managed by the tool.
So this is one of the ways, one opinion to introduce null safety in your application. There are many others. There will be a blog post soon, I believe, about that. But here we marked an entire package as null marked, and now the build checks will run into some problems. So here, it's actually telling us that we're returning something that might be nullable when the method itself is declared as non-nullable. The return type shouldn't be nullable.
So we could use some utility from the Spring Framework that you probably use. There's also the utilities in the JDK, as you know, objects, requires, non-null, etc. What's interesting is that it's custom code, right? And that code, JSpecify understand that if you provide something that's null, an exception will be thrown, so you're never going to reach the next line.
So if you perform just a if check, if this is not null, error-prone and Nullaway will understand that natively. But for other utility methods like this, if we look into that method, we can see that it's annotated with @contract. So this is a contract annotation, where with some kind of syntax, you can say, well, if something is null here, it's going to return false. So, or it will fail, rather. We'll throw an exception. So with that, the compile time checks can know that, OK, from now on, I can assume that this is not null anymore. And this is why the warning about nullability will disappear as soon as we add that check. So yeah, if you do something like this, the check will disappear as well. Okay, so there are many ways. @contract annotations are not required, and I think the JSpecify group is working on ways to, let's say, have it less frequent use or need. But right now, this is what we have, and we've fixed the first error, I guess. Do we have other nullability errors?
Yes, we do. Also, something that we didn't mention yet is the way you can express nullability is actually very advanced. You can specify them in generics. You can specify them, differentiate between the container and the object. So for instance, you could say that an array can be null, the array itself, but or you could say that elements in the array can be null, but the array itself can't be. Same thing for lists, etc. So we do have still an issue. That's an issue that you might come across if you're using the aware interfaces as a way to get some callback being injected, or if you use setter injection, for instance, that's going to happen definitely. In this case, we implement application event publisher aware, which gives us the publisher, event publisher. And that's not working because the field is not initialized. So essentially, what we have to do is either flag the field as being nullable and then have to deal with the fact that down the road it might be nullable and add extra checks. Or we could suppress the warning because we know the container is going to inject the publisher before the bean is being used. Of course, there's an easier way is to inject the publisher in the constructor itself, but we wanted to show you the kind of issues you're going to go through.
So here we can tell that we want to opt out from the checks because we can teach null away that this is going to be initialized at some point. We're sure of it, so they don't need to complain that this thing might be null at runtime. So we've fixed our nullability checks.
Do we want to look a bit about the details about JSpecify?
Yeah.
Okay.
So this is one big feature in the Spring projects for this major version, but this is not like a push to adopt it right away in your apps. There are several things that we discovered along the way and that we really want to give you as advice. So first of all, you should be on Java 24 Plus because some previous versions, it's very much involved in the compilation process, those checks. So it needs a lot of information. In some previous versions of Java, there were like some false positives. So use Java 24 Plus if you want to do null safety like this.
For the build, right? So you can still use 17 for the runtime if you want to.
And then it's really a question about, are you an app or a library? If you're an app, then you can basically do whatever you want in your team. If you're a library, you must know that it's somewhere between source backwards incompatibility and a runtime incompatibility. Because along the way, when you fix those issues, you might add assertions. And those assertions will change the behavior because they'll throw exceptions when maybe before it was maybe working for some reason. It can be a source compatibility problem, especially for your Kotlin users, because Kotlin users, they won't see that as a warning in their build. The actual null safety information is directly built in Kotlin types. So if a Kotlin user is using your Java library, they will see it as a type change in their own code base. So they will have to adapt, change their code, and recompile. So this is a very important change depending on your situation. You should also know that this is very much a viral thing. So we only did that for one package, but chances are this package is used by another one. And if you sprinkle null marked or in several places, you can think it's one of these where you start somewhere and you have 100 warnings, you fix 50, and you rerun, and you got 100 more. So it can be very viral. It can take a long time. But this is very useful because along the way, you can very much rethink contracts. Like I think Stephane.
Yeah, on Spring Web Services, moving to JSpecify actually was quite interesting because you start reconsidering the old API that you call code that hasn't changed for a while because Web Services is a project that's mature. There's no big change into it, and so you have null checks in your code, but it turns out that they are actually unnecessary. If you look at the implementation, that throwing an exception, sometimes it's not really easy to spot. But one thing that's actually quite changing a thing is once you start putting nullable in your code base and you see how viral it's going to be, that makes you rethink that potentially that's not the wrong approach, and either you should add a check or you should verify that's actually the case. So it's actually pretty interesting.
Yeah, and on top of that, you as a team in your Apple library, you should agree on the rules and the tooling. So what kind of tooling are you using to enforce that at build time? Is it just warnings? How are you checking it? Where are you checking it? And like what is the standard in the team that you want to adopt? And once you have like experimented a bit or you have answered those questions, then you can plan accordingly, because you like if you read point 2 and 3, if you do that in a maintenance version, it's not going to happen. Like it's going to be problematic for your users. So you want to do that on your own time when you have enough time scheduled and when you think it's a good trade-off for your team at that point, because it will bring value to your team and to your app. It's just that if you go there and you don't plan accordingly, it's going to be like a huge strain on your team because it's bigger probably than you think.
Let's go with new feature.
Yep. So now that we've seen JSpecify, we can think about API versioning. So we've got a REST API with our app to queue players, and we would like to add a new endpoint. But we'd like to do API versioning. So we know that API versioning is a controversial theme at best in the REST community. Some people say you should do it like this. Some people say don't do it. We're just providing several ways, several strategies to implement that in your application easily, because we realized that even if you had your own opinion and if you want to do it, then it was too complicated and lots of boilerplates. So what we can do right now, there are new attributes in the mapping annotations with a version flag, where here we want to go, our new version of app of the API is 1.1. I guess the existing one is 1.0. And we want this endpoint to be just available to the new version because we want to, that's our strategy for, it could be an existing endpoint in 1.0 and a different one with a slightly different body, response body, for example. That's very much possible. So here our controller, it's 1.0 plus for versions, like what it can do, what it's capable of. And we have a 1.1 version endpoint. And now you need some kind of global strategy to explain how you deal with versioning in your API, REST API. So in the WebMVC configurer, there are new methods, one including configuring the API versioning. And with the configurer, you can say, like, if the client doesn't express anything about version, the default version I want is 1.0 or 1.1.
1.1. So
here we want 1.1. If the client says nothing, we assume that the client is requesting 1.1. Then how do we know which version is required by the client? You can go by query parameters, path segments, your custom strategy, but here we're going to use a request header, and we're going to use API version for the name. And as for the supported versions, we can list all the versions that we support, and all the other versions are not allowed, basically.
All right, so let's have a look to running this.
Okay, so we have that, and now we can use the new API to see how many people we have in the queue.
Yeah, probably need to restart to make that into account.
Yeah.
Because no DevTools for some reason, I don't know why.
We didn't do it, yeah. So the new API works. We didn't specify any version. We've got the new API, and it works. Now, if we test with requesting 1.0, then we get a 404 because the 1.0 version doesn't exist for this endpoint. So we get a 404 as we do. There are other ways as well to have strategies. We have deprecation strategies, so you can add automatically through configuration headers stating this version is deprecated, look at this link, so on and so forth. So there are lots of ways to adapt to your own strategy, like to extract information about the version in several ways, so not just the header, but in combination of others, including your own strategy. So API versioning works on the server, but it's a full story, so it also works on the client. On the Spring clients, when you're requesting an endpoint, you can request for a specific version, and you can configure the strategies the same. So here, we're going to write a couple of tests. They might be a bit synthetic because we're half testing our app and half testing our configuration and a bit the framework, so they're not really representative. But here, you can see that we're sending a request to that new endpoint, and we expect, without providing any version, we expect to get the answer we want.
From the mock, yeah.
From the mock. So that one works. And now we are testing the framework behavior, which is inserting the version in an API version header. And if we want to go, like, I'm sending this request for version 1.0, then I'm expecting that I'm getting a not found. So we can see that we're testing the case that we showed earlier with the 404 doesn't work.
And we're supposed to be able to inject the REST test client, but as you've seen on the first slide, that's where we realized that it wasn't implemented. All right. Cool.
So we've shown API versioning, but now we want to show something different. We can introduce some fake instability in our remote services. So we're making 2 sequential calls to get the information and the stats for our user. And now what we want to do is we roughly want to have 20% failure on one of the endpoints. So we're sending a request to our fake backend. And when we're queuing more players, what we should see is some failures. So yeah, we're seeing a few 500s, and now a few calls are failing.
Not much, because it's 20% failing.
Yeah, 20% out of.
Oh, there's a bit more now.
Yeah. Mm-hmm. So let's assume that we're in production. We don't know really where the error lies because there are many remote calls and we don't know what happens. One way and one thing that we want to demonstrate this time around is the fact that requested by the community, we've been working on making OpenTelemetry setup easier in Spring Boot applications. And so now you can just go starter OpenTelemetry, and we will auto-configure the entire stack you need. So micrometer for the Spring observations and the relevant micrometer registries, and how to export traces and metrics in the OTLP format that all the OpenTelemetry compliant collectors know. And for that, we're going to use a local service. We're going to use a Grafana Docker container with a collector on the port 4318.
So we need to configure that in our app. I haven't opened it yet.
And for demo purposes, we'll also tell our application that the tracing rate should be 1.0 because we want to trace everything. Don't do that in production unless you're very wealthy. But we'll do that in our app, and we'll push the metrics and traces to the collector.
Something also interesting we talked about the code, the fact that you don't have the code in your IDE if you do not opt in for a certain feature. That's also the case for the metadata. So I've just removed the starter that we've added, and then you can see that those properties, they're not known. And the IDE tells you, I don't know about that stuff. That's pretty useful.
And just an aside, if you are a happy user of Actuator, but you just care about Actuator for one of the reasons, This is a very good news for you because you can get observability without actuators. Here, that's what we get. We're pushing metrics and traces, and we don't have the actuator endpoints and all the infrastructure that goes with it. If you just want actuator for the health endpoints, but you don't care about observability, it's perfectly fine. You can do that right now with Spring Boot 4.
All right,
so now
sending some traffic and seeing what's going on.
So if we look at, so we don't have a specific dashboards. We're just looking at exploring faders. So if we look at one fader here, what we can see is, can you see the trace?
Yeah, I'm trying to get the
traces.
That's strange. Yeah, there we go. This one, maybe. Yes.
Yeah, so if we look at the traces, what we got is one trace, so the overall HTTP call to our application. And then you can see two remote calls. So the blue lines are actually the traces on the remote server side. So we're tracking the entire thing across the network. And here, first call is fine.
Yeah, the profile is fine. And then the stats, you can see it.
So we have a fader from the statistics service with a 500. We can see the actual URL. We can see even the library version. And we know that it's an error, and we can extract more information from the trace or other metrics. So this is already a good opportunity, and we know that there are ways to fix that. There are several ways. We can do better failure management on our side, or we could, for example, we could retry that same call.
And if you know Spring Retry project, the Spring Retry project provides that kind of feature, and we've decided to move some of it, or re-architecture of it in the Spring framework itself. So the portfolio has moved to this new API that we're going to show you, and the Spring Retry project is going to sunset. It's not going to be ported over to Spring Boot 4. If you are using it, don't worry, it's still working. It's just that we don't promote those API ourselves. So there is a new system that you can use in Spring Framework, which is called Retryable. And Retryable, you could give it the exception that you want to retry for. What that means essentially is if I have any client-related exception, please retry. If you have a null pointer exception or illegal state or whatever, it won't. You can use include, exclude. So that's what I'm going to say, exclude.
Yeah. By default, it's retrying 3 times and catching everything with default values. Here, we want to tweak things a little bit. So just that type of exception, we don't want to delay too much after a failure, but we also
maybe
200. And there's also you can change the max attempts or the multiplier here because we don't want to add the same exactly at the same time. Here we want to do a 1.5 multiplier. We can also play with the jitter to add some randomness if we want. So there are a lot of things that you can tweak. There's an annotation model, but there's also a programming model that you can use. But here, for failing endpoint, you're changing your mind all the time.
I know. If there's no multiplier, so the default value is 1.0, it's essentially a fixed backoff for the value of the delay. Then otherwise, it starts to expand. Then you have a delay and max delay, which gives you the ability to bound what the max delay will be. And jitter, as Brian explained, is a way for you to add some randomness.
So adding retryable is not enough. You need to enable this globally in your application. So for that, you have an @enable annotation, enable resilient methods. It's not about just retryable. We have also a concurrency limit. If you want to limit concurrency on some methods, you can check out the documentation for this new feature in Framework. It's generally useful, and you don't need to add another library, and we simplified greatly the model. So it's a nice tool that you can use these days. So now we shouldn't be failing. We have a 20% failure rate. So if we look at the last 5 minutes and we get some traces in, we can see that we're not failing anymore. And if we look at some traces, some of the recent ones, that one, maybe? Yeah, so here, instead of having one remote and then one failure, and that's it. Here we can see that we have two failures in a row. So we're retrying 2 times. So first failure, second failure, and then third one is a charm.
Retrying 1 time.
We retried just 1 time?
Yeah, because that's failing and that's retry.
Oh, okay, yeah, okay. Yeah.
I'm joking with that because it was something that was quite hard to grasp because Spring Retry has this notion of max attempts, and it takes the initial request that led to the failure in that, whereas Spring Framework does not. And so it was a bit funny to explain that in the doc for the migration. So you could see also the randomness, like a bit more delay there for the third attempt. Yeah,
the third attempt.
It tripped again.
Second retry.
Yes. All right, so that is quite cool.
So we have that feature, but now we're still not super happy with our application. But let's move back to the slides first,
Right.
because we want to give you an overview of so that was yeah. Okay, so here's an overview of the other things that you can expect from Spring Framework. So we showed resilient features, which is Spring Retry revisited. So we simplified a lot of the concepts. So it's really contained and minimal. We've got new clients in the realm of RestClient and JDBC client. So now we have JMS client.
And maybe we were really quick about the testing of the API, but REST test client is actually new in Spring Framework 7 as well.
Right.
So if you use the web client and web client test provides some assertions on top of the programming style. REST test client actually follow the same pattern. So you could even, to some extent, you could even swap from a web test client to REST test client, and the rest of the API will follow. It's really designed so that you have the same assertions. Of course, for the reactive types, it's different, but the assertions and the programming style is quite the same.
One feature that would require an entire talk is the HTTP interface group. So we already delivered in previous versions HTTP interfaces where you can write an interface and it'll create a REST client for remote service automatically for you. And we got feedback from the community that while it's easy to have 1 or 2, when you have dozens of them, it gets tricky to set up. So interface group is a nice way to configure a lot of them and regroup them under categories. Just like you would have one client for GitHub APIs with many different clients, but under the same HTTP client with the same properties, headers, and timeouts, and so on. So it's really a framework for configuring many clients and setting them up in a nice way. We did changes around HTTP message converters. So right now in Spring Boot 6, configuring HTTP message converters on Spring MVC or clients, it's not as good as what we did later in web clients. So we have a new feature that mirrors that setup. So now it's way easier to express your preferences for JSON codecs or XML codecs and whatnot. So the setup is easier. One thing that would speak to Kotlin users, we got a lot of feedback that when you're using Kotlin with coroutines, you're losing the current observation in your context. So it's not that great for observability. And now we delivered this feature, and we're in the process of making it automatic for you. But right now, you can already use the propagation element operator to do that with your coroutine, so that it's automatically propagated, and you'll finally get nice and complete traces in your Kotlin apps. And finally, because you should be using Java 24+, in Spring Framework 7, we are introducing class file API support. So when Framework is doing when Framework is looking at your code by doing bytecode analysis without loading classes for looking at annotations and stuff, historically, we've been using ASM, and now if you are on Java 24+, it's automatically replaced with the class file API support in your app. So we're still using ASM for some parts, but this is the beginning of that story.
Let's maybe talk a little bit about the Road to GA blog post. So this is a series of blog posts that we've announced, and we already have like 4 of them being released. every Friday. Is it Friday? I can't remember.
Tuesday?
No. Tuesday. Every Tuesdays up to the GA, we will publish a blog post about some of the features that are coming to this new generation. So that one was actually released quite recently by Brian. It explains the state of HTTP clients and the soft deprecation of REST template and your options going forward. There is also the Jackson 3 story. So as you may have heard, Jackson 3 went GA like last week, I think. And we do have support for Jackson 3 and moving towards Jackson 3, deprecating the Jackson 2 support that we have. So that's explained in more details in that blog post. And if you're interested, there is quite a bit of other ones coming up. Spring.io/blog if you're interested to read about that.
So we have 4 minutes. I think we can do the last bit. Do you want to do it?
Do we want to do it in 4 minutes?
Yeah, I think it's doable. So one last bit we want to show as a nice thank you note to the Java team. So because we're on 25, we want to test new things as well. We want to see how things can improve our application and if it works out for us. So what we can do is enable preview features in our application. So it's the compile tasks and testing and run tasks. So we enable preview features in our build. And as we made the point earlier, we are making 2 remote calls in a row. So maybe we can experiment a bit and we can use the structured task scope, the structured concurrency feature that was introduced recently and is still in preview mode. So that's why we have the enable preview flag. So here, our goal, instead of having those calls being made sequential or opting in to using Reactive with web client, we want to parallelize things in a simple imperative way. So this is very basic, but still it shows that it works in our application. So here we'll scope fork the first task, get the profile information. Same thing for the second call, we'll get the stats. And then we'll join both because we want to wait at this point for all the information. And now that we have everything, we can get the information as usual and continue on our way. And this one throws, so yeah, we'll add throws interrupted. So if we run our app, we're not going to show traces and everything, we don't have time, but if you run a simple request to queue a player instead of 400 milliseconds, hopefully it should be faster because now we're parallelizing. So
it's the first request. So
first request, we're at 300, and now we're at 200 something. So now we can see that they're both happening in parallel in our application. And that was a really simple change in our app. And it's also a good way for you to try things out, preview features in your app, and also give feedback to the Spring team and the Java team about those upcoming features.
All right, yeah.
We had time.
We had time, you're right.
So if you want to look at the demo, we've got a repo with all the commits one by one and like important commit messages with explaining what we did and why and so on.
All right, so we only have 1 minute left. So if you have questions, please come here and we're happy to chat with you. Thanks very much for attending.
Thanks very much.